Hi, I want to talk about functions. And so this is the first three chapters of the first three sections of chapter 1. And really we want to talk about what makes a function. And so I went into our Pearson little grapher, and I put it up here. This is the one that comes with your book. If you have a graphing calculator, those work great too. And I just put in a random thing. So first of all, a couple of things about notation. So if we go up here, this is the notation that we use. So we have F and then the parentheses, the X. The X kind of tells us, or the parentheses X the X tells us that that is the dependent variable that always changes, or the, let me rephrase that, the independent variable, the one that you can always pick a value for X. And then the F of X is the function output, and that would be what we call dependent, because it's dependent on your choice of what you pick for X. So I just put in a random one, x cubed minus 5x squared minus 1/2 x, and you can see that it's plotted. And I want to point out some things on this graph that is important. Okay, the first one is the y-intercept, and that is where the graph crosses the y-axis. So this is the y-axis. And at the moment, we see that that happens right at the point 0, 0. Just happened to be by design. And it's not always going to happen at that point. The next thing that we'd want to talk about is the x-intercept. And the x-intercept is where the graph crosses the x-axis. And you'll notice there are 2 points on this one. We also have 0, 0, but then we also have, which is about 5 and then 0. So those are our x-intercepts and our y-intercepts. If you've had algebra before, you probably have discussed these. So these aren't particularly new concepts. There are a few things that I just want to make sure that we all have the same notation for. One is increasing and decreasing. And so increasing is going to be as my graph gets bigger. So you'll notice from about 3.3 all the way up to infinity, we notice that it gets bigger. But I could also look at, say from like negative infinity all the way up to 0, you'll note it also increases. But then we also have this part here from 0 to about 3.3 where it's decreasing and where the value of y is getting smaller. So there's increasing and decreasing. We could talk about something called a maximum and a minimum. And this graphing program actually shows you those with little dots. So here's a maximum and here's a minimum. We would call these local maximums or minimums sometimes, depending on how you want to organize that. But then the other term that we would want to talk about is we'd want to talk about concave up and concave down. And so the way we kind of think about it is concave up is if the graph sort of smiles. And so see how you can kind of make a smile on here, so it's concave up. The other one would be if it makes a frown, and this concave down. That's not particularly in your book, and we're not going to necessarily quiz you over, but I want you to be aware of that terminology because it shows up later in your math life. And so we have that there. The last thing I want to talk about in a type of, like just what a function is the domain and the range. And so the domain is the all possible values for x. The range is all possible values for y. In this case, the domain and the range is everywhere, but let's say that we had a function like 1 divided by, and I'll just make this interesting, say x minus 3. Well, 9x minus 3 works too. And you notice that now my graph kind of goes over here and over here, but it will never equal 0. And of course, that's because 9x minus 3, I can't ever get that to be right at 0. So it's not actually, yeah. Anyway, so that would be domain and range. So that, we can talk about how like that particular point is excluded. Also anything that we take like the square root of -1, anything like that would also be excluded in graphs. So if we were to say graph y equals just x to the 1/2 value, you'll see that we can't have negative numbers because of course square roots can't be negative, but we can have this positive one. The other thing that I should point out with functions is that they have to pass the vertical line test, meaning that I can only draw a vertical line through one point. I have y equals x to the 1/2, but if I was to duplicate that and I had y equals the negative of that, you can see how it's like that bottom part. If this was all one function, I could draw a vertical line through here and it would happen more than once. And so I can't, of course, use that. So those are some definitions of the functions. And we're going to now kind of talk about what we might call function transformations. And so function transformations are ways that we can change the value, change our function to make them look good. And this works much better with lots of color, and we don't have tons of color. But I'm just going to do y equals x cubed because it's a graph that we kind of know about. Okay, so as you can see, this is about what y equals x cubed. And then I should be able to, let's kind of play with this a little bit. So one of the things that I can do is I can say subtract 5 from this. And then you'll notice that now this goes down. And so what we'll often write this as is your book will use the terminology plus k, and of course we don't know what k is equal to, so that this is not sure what it was doing. Oh, well, that's convenient. Now we can actually kind of change our value of k. That's actually kind of fun. And so you can kind of see as I change what my value of k is, what happens to the graph. Let's actually do an additional one on this. Let's take this and we'll do x minus h. And so h is going to move us on the x-axis. So you can see if I go left and right, I can move this to the 0. And I definitely encourage you to pull this up with your book and try this for yourself so you can kind of see how things work. And then let's just kind of continue on with that theme. Let's call this A. And so A is what we would call a vertical stretch. And so as I make A bigger or smaller, and when it's negative it flips, it's stretching it to the vertical component. Verse is, let's see here, what's the easiest? And then I will do a B here, shall we say. And the B is going to be our vertical stretch. So it's going to kind of make it a little bit on the fat or the thin type of thing. So I encourage you to kind of pull these up and play with them a little bit, because it's a great way to look at the different ways that a function can work. And you can play with this, and this is a great tool. I love the little sliders. The sliders are fun. So if you haven't done a slider, definitely try that. And it looks as though you can press the play button and move back and forth on that. And so you can kind of see all the possible different values. One of the things about transformations is you want them to be colorful when you're looking at them and you're looking at the difference of them. Your book won't use these terms per se, but I actually really like it to write like an x minus h type of thing, because the minus sign kind of reminds me when it is a minus sign, it moves. Here, I can make these all 1, I'm sure, easily. 1. A equals 1, h I'm going to be playing with, and k I'm going to make equal to 0. And so now we just have this transformation. As I make h bigger, you notice that I'm moving it over into the left side. And the reason why that works is because I have a minus sign here. Or I'm sorry, I'm moving it over to the right side, which I think makes a little bit more sense. And then if I make it smaller, then it moves over to the left side. And so I tend to write it with a minus sign, but your book uses a plus sign, and I really don't care how you care to use it. But you definitely want to use it. And then lastly, I want to talk about piecewise functions. And let's see if we can do this with this one. Let's try and delete this one entirely. If I say y equals x equals 3 for, and then I'm just going to specify where I want to do that. I'm going to say that between like minus 10 and 0. Let's see how well our graphing program works. Let's see here. Let's try a less than. Yeah, there we go. So that I can specify exactly. So from minus 10 to 0, my graph is y equals x cubed. But then let's say that my graph is 3x squared. Oops, wrong one. Squared minus 10 for the values of 0 to, just to be convenient, we'll just again do 10. So this is what's known as a piecewise function. You'll notice that it actually kind of changes the way, because there's like a jump, and there can be a jump in there. I could make this less than or equal to. I would just fill that in as a dot. And so piecewise functions are a way you can define a function within a different part of your domain, and you would break it up into as many parts as you need to. So that is a quick demonstration of the important parts of sections 1.1 to 1.3. If you have any questions, of course, please let me know. Thank you very much.